Good morning, everyone, and welcome to today's lecture. In today's lecture, we are going to complete whatever remains of the chapter in AC. I hope everyone is there. I've lost your video feed.
1 minute.
Okay. So, I'll give you time to correct it. So, as I was saying in the previous lecture, we had started with the meaning of the terms, and the last thing that we discussed was power in a AC circuit. We had seen that whenever we talk about power in a AC circuit, which power are we talking about? When we are talking about power in a AC circuit, we are always talking about the average power which is given out in one complete cycle, and the formula for average power, you can use VRMS into IRMS into cos phi, or we can use the formula of I square RMS multiplied by R. Cos phi is known as the power factor of this circuit. Now the value of this power factor depends on the type of circuit. If it's a pure resistive circuit, the value of phi is 0, so cos phi becomes 1. If it is pure inductor or pure capacitor, the value of phi is 90 and the power factor becomes 0. We call such current as wattless current. Why we call it as wattless current? Because there is no power consumed in such a circuit. If you have a resistor or a capacitor in combination with a inductor or a capacitor, if you have a combination of inductor with resistor or capacitor with resistor, the value of phi will lie between 0 and 90. In that case, your power factor will lie somewhere between 0 and 1. Do we remember this?
Yes, sir.
Let me ask you this simple question here. When a voltage 200 root 2 sine of omega t plus 15 degrees applied to an AC circuit, then the current in the circuit is found to be this one. What is the average power consumed in the circuit? I'll give you 2 minutes to give me the answer. Option 3. How did you get this option 3? How did you get option 3?
Power consumed is VRMS into IRMS.
Average power is VRMS into
IRMS.
IRMS
Cos phi.
into cos phi. What is the value of VRMS? RMS value of voltage, how much is that?
V naught by root 2, that is 200, sir.
V naught by root 2, that is 200 multiplied by the RMS value of current,
Root 2, sir.
that is 2 divided by root 2, so that becomes root 2 multiplied by cos phi, where phi is the angle between current and voltage. Who is leading here? Current is leading or voltage is leading?
Current.
Current is leading. By how much angle is the current leading? Here the angle you can see initial phase is pi by 4, means 45 degrees. Here the initial phase is 15 degrees. So how much is the phase difference between current and voltage?
30 degrees.
30 degrees. So multiplied by cos of 30 degrees. Cos of 30 is
Root by 2.
Root 3 by 2. So you end up with the answer of 100 root 6 watt. Do we understand this?
Yes.
If I would have put one more question here, what is the value of the resistance R of the circuit? What is the value of the resistance of the circuit? Then what would be the answer? I'll give you 2 minutes to give me the answer. 50 root 6. How did you get that answer?
Sir, P average is equals to IRMS square into R.
So that is again equal to IRMS squared multiplied by R. That is the formula that you should remember. IRMS. So IRMS is root 2. So it is root 2 squared multiplied by R. Root 2 squared is 2. So the value of R becomes 50 root 6. Do we understand this?
Yes.
Yes or no?
Yes.
Everyone understands this?
Yes, sir.
The next question in the same question so that you understand how things are done. What is the value of Z? What is Z? What is Z?
Equidance. Impedance.
Z is the impedance of the circuit. So now you have the chance to find out the impedance of the circuit. I'll give you 2 minutes to give me the answer. How do you get the value of the Z?
We are RMS by IRMS.
So you can find it out from VRMS divided by IRMS, or you can also divide it by V naught divided by I naught. Both are same. So it will be equal to 200 root 2 divided by 2. So it becomes 100 root 2. Do we understand this?
Yes.
We could have also found out R by Z is always equal to cos of phi. Could have also found it out from that way. Even from that way, you will see that you end up with the same answer. So no matter how you do it, you always get the same answer. Do we understand this?
Yes.
Okay, let me give you another question. Question number 2. We'll write it in short. The value of VRMS is 200 volt and the value of IRMS is equal to 50 ohms. If the resistance R of the circuit is 10 ohms, find number 1 power, number 2 cos phi, number 3 the value of Z. I'll give you 2 minutes to get me the answers. Yes, tell me.
Sir, power is 25,000.
You have to first find the power. Power is, you can find it out from this formula, I square RMS multiplied by R. Yes or no? So you can do 50 square multiplied by 10 and that is the power. Do we understand this?
Yes, sir.
Now, what after this? How do you find out? How do you find out the value of cos phi?
Sir, Sir, power is equals to VRMS into IRMS into cos theta.
Correct.
From that we can find it.
From that you can find it. So this is again equal to 200 multiplied by 50 multiplied by cos of phi. From there you will get the value of cos of phi. Once you get the value of cos of phi, you can write it as r by z. You already know the value of r. You will get the value of z. Do we understand this?
Yes, sir.
Everyone understands this? We understand this? Yes or no?
Yes, sir.
Shall we move ahead then?
Yes, sir.
So, we have seen the concept of power and how it can be calculated if VRMS and IRMS are given to you. It is quite simple to get it. We will come back to this power when we are when we will be going ahead and looking at more things. We will come back at this. Right now, up till this point, let us move ahead with the next thing. We have seen that this power factor or this phi, the value of this phi, which is the most important aspect in this chapter, it depends on the type of the circuit. So now let us move on and see the different types of AC circuits. Different types of AC circuits, and the first circuit that we are going to deal is the simplest one, and that circuit is which one?
LC.
That circuit, the simplest circuit, is a circuit which has only one element, and that first element that we are going to deal with is resistor. So case number one, pure resistive circuit. We are going to deal with a circuit which has got pure resistance. This is the circuit. Now, whenever we are dealing with AC circuits, we cannot draw a battery because AC circuits don't have battery. So, AC voltage is provided by an AC generator or an AC voltage source, and this is the symbol of a AC voltage source. Have you seen this symbol like this?
Yes, sir.
This is the symbol of an AC source. Now, the value of this AC source in most of the cases is going to be given like this. This is how we will start. E is equal to E naught sine omega t. This is the value of this AC source. It keeps on fluctuating. It's a sine wave. Do we understand this? At any time in the circuit, let us say that the current in the circuit is I. At any time in the circuit, let us say the current is I. Because of this current in the circuit as I, you will have a voltage drop across the resistor. We will call it as VR. Voltage drop across the resistor. Do we understand this?
Yes, sir.
So the voltage drop across the resistor will be equal to I into R. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Now, if you apply Kirchhoff's law in this circuit, you will understand that this VR will be equal to E. Yes or no?
Yes, sir.
VR, the potential drop across the resistor, same potential drop will be across the AC source. Whatever the potential drop is across the AC source, that will be the same potential drop across the resistor. Do we understand this?
Yes.
or I can write I into R will be equal to E naught sine omega t. Yes or no?
Yes, sir.
From here, I can find out the value of I. The value of I that I will get will be equal to E naught by R sine omega t. Yes or no?
Ye-
Yes or no?
Yes, sir.
Now I can understand. This is how I have completely solved the circuit. How I have completely solved the circuit. See, I started with an EMF E which was equal to E naught sine omega t. Yes or no?
Yes, sir.
From there, I can find out the value of current in the circuit and I can write the value of current in the circuit as I naught sine omega t. This I naught is equal to E naught divided by R. Yes or no?
Yes.
I naught is equal to E naught divided by R. Do we understand this?
Yes, sir.
Now, this E is actually potential drop across the resistor R. Yes or no?
Yes, sir.
Now, from here, what do we see is this VR. We will look at this VR and we will look at this current which is flowing in the circuit. This voltage across the resistor and current across the resistor are in the same phase. Yes or no?
Yes, sir.
That is an important thing that you must remember. VR and IR are in what? Are in same phase. Do we understand this?
Yes, sir.
Now, if someone asks you what is the average power in this, you can simply find it out by multiplying I square RMS by R, or you can also find it as VRMS into IRMS into cos of what will be the angle of phi?
0, sir.
Cos of 0. Um, so your circuit is solved. Do we understand how we have solved this circuit? Yes or no?
Yes.
Now, what is remaining is you will have to draw the phasor diagrams of this circuit. And how do you draw the phasor diagram of this circuit? Let me see if I have this so that okay. Let me use this one. So I can draw it starting from here. Let me see if I can get this on the picture. I think you can see this. This is the first graph that I have drawn. This is the graph between, let me write it as VR and IR. You understand the meaning here?
Yes, sir.
So, this is how this VR or IR change with time. As you can see, they are in the same phase. They are in the same phase. This is the voltage across the resistor. This is the current across the resistor. They are in the same phase. They are doing everything together. Do you understand this?
Yes, sir.
They are in the same phase. They do everything together. Now I can draw. Now I can draw their. Now I can draw their phasor diagram as well. And as you can see in this phasor diagram, they are in the same phase. Do we understand this?
Yes, sir.
Everyone understands this? That they are in the same phase?
Yes, sir.
Okay, I could have drawn this phasor diagram in this way also. I could have drawn it like this. Okay, let me use this one. I could have drawn the phasor diagram. I could have drawn the phasor diagram like this. This is your x-axis and y-axis. I could have drawn the phasor diagram like this. First, I will draw the phasor of voltage. The phasor of voltage is E naught here or ER here. Sorry, not writing it as ER. Let me write it as VR. You understand the meaning of VR?
Yes, sir.
What is VR?
Voltage across resistor.
Then if voltage across resistor is here, where will be the current across the resistor? It will be a bit smaller, assuming that resistance is more than 1 ohm. So they are in the same phase. So you understand what you have to do. You have to draw the diagram and write all these things. If you can write all these things, look at the diagram, look at the board. If you can write all these things on your own, well done. If you cannot write it on your own, look at the diagram and write it. I'll give you 2 minutes to do this. This was the case of pure resistance. Let us now move on to the case of pure. Let us move on to the next circuit. And, which one will be the next circuit that we are going to deal? Yes, which one should be the next circuit that we should deal with? The next circuit that we are going to deal with,
Is pure capacitance, I guess.
we will deal with pure capacitance first. So we now move on to a circuit which consists of pure capacitance. A circuit which has pure capacitance. Now, if a circuit has pure capacitance, that means it only has a capacitor connect to it to a AC source. This is how the circuit would look like. Yes or no?
Yes.
At any time in the circuit, you will have a current I flowing in the circuit. Let us say this may get positively charged, this may get negatively charged, and there will be a potential drop across the capacitor. Let me call it as VC. Do we understand this?
Yes.
Now, at any time in the circuit, I can write this VC will be equal to E. Yes or no?
Yes, sir.
This VC, potential drop across the capacitor, is Q by C. Yes or no? Q is
Yes.
equal to CV is the only formula that we have studied. So this Q will be equal to E naught sine omega t. Yes or no?
Yes, sir.
So I can write this Q will be equal to E naught C sine omega t. Yes or no? The current in the circuit will be dq by dt, and if you find out the value of this dq by dt, you will get C into E naught. Sorry, I will write it like this. C, oops, I will write it like this. Omega into C into E naught cos omega t. Yes or no? The derivative of sine omega t is cos omega t. Yes or no?
Yes, sir.
Then I can write this current in the circuit I as E naught divided by 1 by omega c. Cos omega t can be written as sine of omega t plus pi by 2. Do we understand how I am trying to write this? Yes or no?
Yes, sir.
Now, once you understand how I've written this, now we can understand how the circuit is solved and how is this circuit solved. I can write. I start with the voltage. Voltage was E is equal to E naught sine omega t, and from there I found the value of current. Current can be written as I naught sine of omega t plus pi by 2. Yes or no?
Yes, sir.
Now here, this E is nothing but Vc and this I is nothing but current across the capacitor. So I can see current across the capacitor leads voltage across the capacitor by a phase angle of pi by 2. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
This I naught is equal to E naught divided by Xc, and this Xc is nothing but 1 by omega c. Do we remember this Xc?
Yes.
Yes or no?
Yes, sir.
Now, if we talk about the power consumed in this circuit, the power consumed in this circuit will be 0 because value of phi is 90. So the cos phi becomes 0. Yes or no?
Yes, sir.
Everyone understands it till here.
Yes, sir.
Now is the time that I have to draw the diagram of E and I, or VC and IC with time or phase angle. So you can draw the time here, and on this axis you have drawn VC and IC. Do you see this? Who is ahead and who is lagging? You can see current is ahead and voltage across the capacitor is lagging. Do we understand this?
Yes, sir.
Or it has gone above our head saying bye bye. Bye bye, I'm going, bye bye, I'm going, bye bye, I'm going.
We understood.
Everyone understands this.
Yes.
I could also draw the phasor like this. Yes or no? No, yes. Where the voltage, if it is here, the current across is here. Yes or no?
Yes, sir.
I could have also drawn it in this fashion. Let me not write X. If I would have drawn the voltage E naught, sorry, not, why I'm writing E. If I would have drawn the voltage across the capacitor VC here, where would be the current across the capacitor?
Will be ahead.
The current across the capacitor IC would be ahead by a phase angle of pi by 2. Do we understand this?
Yes.
Yes or no?
Yes, sir.
Anyone understands this?
Yes, sir.
One more thing. If I would have drawn the graph of XC with frequency, as you can see, when frequency is very less, XC is very high, yes or no? Remember this XC is 1 by omega C, so it is inversely proportional to omega, yes or no?
Yes,
Or
sir.
it is inversely proportional to frequency, yes or no?
Yes.
For DC, for DC, for DC, the value of F is 0. That implies this becomes infinite. Do we understand this?
Yes, sir.
Let us go on above and saying bye bye. Bye bye, sir. I'm going bye bye. Bye bye. I'm going bye bye.
We understand.
Everyone understands this? Yes or no? Can I have raised hand that we have understood this?
Yes, sir.
Give you 2 minutes to note this down. This was the case of a purely capacitive circuit that brings us to the next circuit. What is the next circuit that we are going to do?
Inductance, pure inductance.
The next circuit that we are going to do will be a pure inductive circuit. And for a pure inductive circuit, let me write the heading, pure inductance. Pure inductive circuit, you can easily draw a pure inductive circuit. It would just look like this, yes or no? At
Yes,
any
sir.
time, if I say the current is I, it will have a voltage drop that will be equal to VL, yes or no?
Yes.
You can write this E. You can write this E. You can write this E. You can write this E will be equal to VL, yes or no?
Yes.
Now, voltage drop across the inductor, if you remember, it will be equal to L into di by dt, yes or no? L into di by dt will be equal to E naught sine omega t. Do we understand what we are writing here?
Yes, sir.
Now, from there, you should be able to integrate and find out the value of I. We are not going to get into that. We are just going to write the value of I, and the value of I that you will get will be equal to E naught divided by omega L into cos omega t with a negative sign, because integral of sine omega t is minus cos omega t. Now this can be written as I will be equal to E naught divided by XL. Do you remember this XL?
Yes.
Into sine of omega t minus pi by 2. As soon as you write it like this, then you can say that the circuit is solved. We started with E is equal to E naught sine omega t, and this is nothing but the potential difference across the inductor L, yes or no? I got the value of current as I is equal to I naught sine of omega t minus pi by 2. So I can see this current across the inductor lags the voltage across the inductor by a phase angle of pi by 2. Do we see this?
Yes, sir.
Everyone sees this?
Yes, sir.
This I naught will be equal to E naught divided by XL. this XL is nothing but equal to omega L. Do we understand this?
Yes, sir.
This XL is nothing but equal to omega L, and this XL will be equal to 2 pi f into L. Yes or no? If I draw the graph of this XL, if I draw the graph of this XL with frequency, the graph would just look like a straight line. Yes or no? No or yes?
Yes.
For DC circuit, if you see, for DC circuit, your F is equal to 0, and therefore your XL would be equal to 0, and that is why it behaves just like a short circuit. Do we remember this?
Yes.
Everyone remembers this, yes or no?
Yes, sir.
Now, if you have to draw the time wala graph between your EMF, current, and time, this is how the graph will look like. Yes or no? On this axis, I have drawn VL and IL, and as you can very easily see, who is leading, who is lagging, who is leading, who is lagging.
VL is leading and IL is lagging.
Everyone understands this? Yes or no?
Yes.
Then you can draw the graph, you can draw the phasor in this way as well. The phasor will look like this, current will be lagging behind and voltage would be leading. Yes or no? No or yes?
Yes, sir.
Can also draw the phasor in this way. I can also draw the phasor in this way. I can draw my VL here. If I draw my VL here, where is my current? My current IL would be here. Do we understand this?
Yes.
Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note this down. Here, I think I have forgotten to mention one thing. What will be the power consumed in this circuit?
0, sir.
The power consumed in this circuit will be 0 because the phase angle is pi by 2. So the power would be 0 no matter what happens. Do we understand this?
Yes.
Everyone understands this?
Yes, sir.
Okay. So we are done with the simple circuits. Let us try and see some points about everyone remembers this?
Yes, sir.
Yes or no? Let me solve, let me give you a couple of problems on this so that I'm happy that you understand it. This is the first one. What is the inductive reactance of a coil if the current through it is 20 milliamp and the voltage across it is 100 volt? Remember, whenever any current or any voltage is given, which value of the current or which value of the voltage is given?
RMS.
So always the RMS value. So this is the RMS value of current and this is the RMS value of voltage. From this, you have to find out the inductive reactance. I'll give you a minute to solve it. So how are you supposed to get this one? Remember, we have seen that your value of XL will be equal to V naught divided by I naught. Yes or no?
Yes, sir.
You can also write it as VRMS divided by IRMS. Yes or no?
Yes, sir.
So it is simply 100 divided by 20 into 10 raised to the power minus 3, and that would be your answer. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Okay, this one. A capacitor of 50 micro picofarad 10 raised to the power of minus 12 is connected to an AC source of frequency 1 kilohertz. Calculate its reactance. Yes, how much is the answer you got?
X equal to 10 power 7 by pi, sir.
That is correct. How are you going to get it? Xc, the capacitive reactance is 1 by omega c, 1 by 2 pi fc. Everything is given. F is given as 1 kilohertz and frequency is given as 1 kilohertz and the capacitance is given as 50 picofarad. Do you understand this?
Yes.
Then comes this one. Remember, whenever they give you the value of current or voltage in a AC circuit, it is always the current and the voltage ka RMS value. In a given circuit, the applied voltage is given, the ammeter reading is given, calculate the value of L. How are we supposed to do this? We understand that XL is equal to VRMS divided by IRMS. Yes or no?
Yes.
So VRMS is 50, IRMS is 2. So XL becomes your 25. Yes or no? And that XL is equal to omega L. Do we understand this?
Yes.
This omega is 100 pi. Do we understand this?
Yes, sir.
So once you understand all of these things, you should be able to calculate the value of L from here, and the value of L that you are going to get from here will be equal to 1 by 4 pi. Remember the SI unit is Henry, so the answer is 1 by 4 pi Henry. Do we get this?
Yes, sir.
Everyone gets this? Shall I
Yes.
move on to the next question?
Yes, sir.
This one is the next one, my dear friends. An alternating voltage E is equal to 200 root 2 sine of 100 t is connected to a 1 microfarad capacitor through an AC emitter. Obviously, an AC emitter will read RMS value. I have told you that. What is the reading of the emitter? Give you 2 minutes to give me the answer for this one. So, how are we supposed to do this? We have to find out the reading of the emitter. That means we have to find out the RMS value of current. Yes or no? Now,
Yes.
how will I find the RMS value of current? We divide the RMS value of voltage divided by XC. Yes or no?
Yes, sir.
The RMS value of voltage is 200. XC is 1 by omega C. So it will be 1 by omega. Omega is 100. Yes or no?
Yes, sir.
Multiplied by capacitance is 1 into 10 raised to the power minus 6. And that is your answer for this particular question. Do we understand this, everyone?
Yes.
Anyone having any doubt on this?
No, sir.
So this was the case of purely capacitive and purely resistive and purely inductive circuit. Now what I will try to do is try to put all these things into one table so that at one place you are able to get everything. So this is the first part of this. pure R, pure L, pure C. You can see these voltages and you can see this current. Now remember, whether it is resistance or reactance, they are all part of impedance. Do you understand this? Impedance is a broader term that encompasses everything. So the resistance of a resistor is also impedance. The reactance of a inductor or reactance of a capacitor, they are also impedances. Do we understand this?
Yes.
In first case, the impedance is pure R, so R. In second case, it consists of pure L, so the impedance becomes equal to XL. In third case, the circuit only consists of capacitor and therefore the impedance becomes XC. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then this is the next part of this. In this, we see the other elements. The first element that we see is phase difference. Phase difference between VR and IR. They are in the same phase. Do we understand this?
Yes, sir.
In case of pure inductor, VL is ahead. VL is ahead of IL by a phase angle of 90 degrees. Yes or no?
Yes, sir.
In the third case, current is ahead of voltage by a phase angle of pi by 2. This is the variation of Z with F. Here it remains constant. Here it is directly proportional. Here it is inversely proportional. Do we see this? Yes or no?
Yes, sir.
All the things written together. Do we understand this?
Yes.
Have you noted it down? Are you noting it down or shall I move ahead?
We can move ahead.
Then in the next case, we have susceptance and all those things, the inverse of impedance, inverse of reactance and all that. We have already discussed this. Yes or no? No, yes.
Yes, sir.
So that takes us, we are done with the simple circuits. Simple circuit simply consists of a pure resistor or a pure capacitor or a pure inductor connected to a AC source. In case of pure resistor, the phase angle between current and voltage is 0. Current and voltage across the resistor are in the same phase. In case of pure inductor or pure capacitor, they are not in the same phase. In one case, it is leading. Current is leading voltage by a phase angle of pi by 2. In the case of capacitor, current is lagging voltage by a phase angle of pi by 2. In case of inductor, and in both the cases the power consumed by the circuit is 0. Do you understand this? Now we come to the next type of circuit, and in the next type of circuit what we are going to do is we are going to see a combination, and the first combination that we are going to see is a combination of RL.
Yes, sir.
We call it an RL series circuit. Why series? Why it is series? Because they are connected in series like this. L and R are connected in series. Current in the circuit is I. There will be a voltage drop across the resistor VR. There will be a voltage drop across the inductor VL. Do we understand this?
Yes.
Now, whatever you do, whatever you see, the total EMF E will be equal to VR plus VL. Yes or no?
Yes, sir.
This total EMF E can be written as E naught sine of omega t, that would be equal to VR is I into R plus VL is L into di by dt. Now this becomes a differential equation. If you go to solve it by the differential equation, it becomes very tough. Anyways, we can solve this differential equation in a different way. How can we solve this differential equation in a different way? It's a differential equation actually. You can solve it in a different way. How we can solve it in a different way? Any idea? How this equation can be solved in a different way rather than using your differential equation. Any idea? So what I'm going to do is I'm going to solve it by the concept of phasor diagram. Now this is a series circuit. Now if it is a series circuit, one thing will be same across both the elements of the circuit, across the resistor and inductor. One thing is same. What is same?
I.
The current that is flowing through the inductor or the resistor is same. So what I'm going to do is I'm going to draw the current across the inductor or current across the resistor. I draw I. The current is drawn along x-axis. Then where will be the voltage VR? If current is along x-axis, where will the voltage VR be?
The same axis. On the same axis.
The voltage will also be along the same axis, and that is your VR. Do we understand this?
Yes.
First listen to me, then I will give you time to write. The voltage will also be same along the same axis. Now, where will the voltage across the inductor be? Where will the voltage across the inductor be? Current is along x-axis. Where will the voltage across inductor be?
Positive Y.
The voltage will lead, so it will be along positive y-axis. Do we understand this? The voltage would be along positive y-axis. Do we understand this? This is VL. This is VL. And this is VR. Do we understand this?
Yes.
And this voltage which is applied, the voltage which is applied E is nothing but the sum of these two voltages. But the problem with these two voltages are they are not in the same phase. So it is like addition of two waves which are not in the same phase. Do we understand this?
Yes.
So you can easily add these vectors using the triangular law of vector addition. Yes or no? No, yes.
Yes, sir.
Now remember, whenever we are talking about these phasors, whenever we are talking about the values of these phasors, we are talking about the values, the RMS value or the peak values. Yes or no? So I can write the RMS or the peak values. Now the relation between the RMS or the peak values will become like this. E will be equal to under root of what? VR square plus VL square. Yes or no?
Yes, sir.
Now this E, which is the RMS value of voltage or the peak value of voltage, can be written as I I multiplied by Z, yes or no? So I multiplied by Z will be equal to I multiplied by R, the whole square, plus I multiplied by XL ka whole square. You will see that this I will get cancelled and you will get the value of Z as under root of R square plus XL square. Do we understand this?
Yes, sir.
That means this diagram which I have drawn is actually equivalent to if I would have drawn the diagram of Z like this. R is here, XL is here. The value of Z becomes just like this. Yes or no? No or yes?
Yes, sir.
Here you can find out the value of this tan of phi. If you write the value of this tan of phi, that will become R by XL. Yes or no?
Yes, sir.
You can also write the value of cos of phi. And remember, this cos of phi will be always equal to R by Z. Do you see this from this triangle? Yes or no?
Yes,
Yes or no? This is gone above our head saying bye bye.
we got it, sir.
Everyone got it? Yes or no?
Yes, sir.
Now the circuit is solved. Now whatever we have understood, we can write it in the form of vectors. How we can write it in the form of vectors? The voltage that was given to me was E naught sine omega t. Do we understand this? I could get the value of current. Current will be equal to I naught. Now remember, this is a combination of L with R. When it was pure R, current and voltage were in the same phase. When it was pure L, voltage was leading by some angle. Here, when it was pure inductor, voltage was leading by an angle of 90 degrees. But when it becomes a combination of L and R, voltage leads, but not by an angle of 90 degrees. It only leads by an angle of phi. Do we understand this?
Yes, sir.
So I can write current as E naught sine omega t minus phi because current is behind. Do we understand this?
Yes, sir.
Here we have got a term I naught, and this I naught will be equal to E naught by Z. Do we understand this?
Yes, sir.
This Z is the impedance of this circuit, and we can see that the impedance of this circuit will be equal to under root of R square plus XL square. The value of XL will be equal to omega L. Yes or no?
Yes, sir.
The tan phi for this circuit is R by XL. The cos phi for this circuit will be R by Z. Yes or no? The
Yes,
power consumed for this circuit, I can write the formula as VIRMS into cos phi, or I can write it as I square RMS multiplied by R, because in any case it will lead to the same result. Do we understand this?
yes, sir.
Everyone has understood what I have done here.
Yes, sir.
Everyone has understood this?
Yes, sir.
Now look at this, and if you can do it on your own, that is very good. Now sometimes just to make the question different or a difficult one, probably in the case of IIT-JEE, I mean JEE Advanced, they can ask you, remember this is the total voltage which is applied, this is the current that is flowing in the circuit. They can ask you the value of VR and VI as a function of time. So remember, from here I can write the value of VR and VI. Remember this VR is this I multiplied by R. Do we understand this?
Yes,
But whenever we are doing this I multiplied by R, you must remember that you must also look at its phase. This voltage VR is in the same phase as the current. Yes or no?
Yes.
Now, once you understand this, then you can write the value of this VR. This VR will be equal to I naught multiplied by R. Now, instead of writing this as I naught multiplied by R, you can also write it as the peak value of voltage VR into sine of omega t minus phi. Do we understand this?
Yes.
But once you write the value of VL, now VL will be equal to I naught multiplied by XL, and remember this voltage is ahead of current by a phase angle of pi by 2. So you will have to remember the sine of omega t minus phi plus pi by 2. Do you understand from where it is coming?
Yes, sir.
Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. The next circuit would be RC circuit. What will happen in a RC combination? Yes, tell me. What would happen in a combination of R with C? RC series circuit or CR series circuit. What would happen in a combination of R with C? Can you do it on your own? What would happen in a combination of R with C? Can you do it on your own? You will have a circuit like this. Current in the circuit will be I. The voltage drop across capacitor would be VC. The voltage drop across the resistor would be VR. And you can see this E will be equal to VC plus VR. This E will be equal to E naught sine omega t. This VC will be equal to Q, charge across the capacitor, divided by C, plus this will be equal to I multiplied by R. Again, this becomes a differential equation. But we can solve this differential equation in a different way. How we can solve this differential equation in a different way? Yes. How we can solve this differential equation in a different way?
By phasor diagram.
By the use of, very correctly said, phasor diagram. So how we can use this phasor diagram? This is a series circuit, but one thing is same across both the elements. What is that same thing across both the elements?
Current.
The current is same. So what do? I first draw the phasor of current and I call it I. I call it I and I draw the phasor of current. Then where will the phasor of voltage across the resistor VR would be?
With the same phase.
The value of VR would be in the same phase. What about the capacitor, the voltage across the capacitor? The voltage across the capacitor VC would be behind by an angle of 90 degrees. Do we understand this?
Yes.
Then this E is the sum of two vectors, supposedly not vectors they are, but they are not in the same phase. Now you can very easily see the value of this E, and we are talking about the RMS value or the peak values, that will be equal to, my dear friends, VL square VR square plus VC square. Yes or no? No, yes.
Yes, sir.
Then I can write the same thing in the form of z. Your z will become what? Under root of r square plus xc square. Do we understand this, or this has gone above our head? Saying bye bye, bye bye, sir. I'm going bye bye.
We got it.
Everyone got this?
Yes.
Now you can see it very clearly that the value of this tan of phi, you can write it as r by xc. You can also write it as vr by vc. Yes or no? Again, I'm talking about the RMS value. Yes or no?
Yes, sir.
That solves your circuit. Now you can write the circuit in its original form. I started with E is equal to E naught sine omega t, and I will get the value of current as I naught. Now, is the current leading or lagging or in the same phase? When it was pure resistor, the current was in the same phase. When it was pure capacitor, current was ahead by an angle of 90 degrees. Here, it is not in the same phase, not ahead by 90 degrees. It is ahead, but only with an angle of how much? Only with an angle of phi. Do we understand this? This I naught will be equal to your E naught divided by this Z. This Z will be equal to under root of R square plus XC square. This XC will be equal to 1 by omega C. This tan of phi will be equal to VR by VC. That will be equal to I've written it in the reverse order. See, oh, yeah, have I done the same mistake here also? I've done the same mistake here also, and no one saw this. Oh, this is not R divided by XL. This is XL divided by R. No one saw the mistake. This XL divided by R. Just now I realized that I have done the same mistake here. Tan phi here. This is your XC. Tan phi is XC divided by R, not the other way around. Anyway, so here also I was writing the same thing. It should be equal to VC divided by VR, XC divided by R. XC is 1 by omega C, so 1 by omega CR. But whenever you look at cos of phi, the cos of phi is always equal to R by Z. You can also call it as VR by E. Now, many a times they might ask you the value of VR in the equation form. VR, remember, it's in the same phase as current. So you just multiply current by R and you get the value of VR. Are you able to understand what I am saying?
Yes, sir.
But whenever you write the value of VC, VC lags behind 90 degrees. So you multiply I naught with XC, but you remember in terms of angle, it would be behind by 90 degrees. So plus phi minus pi by 2. Do we understand this?
Yes, sir.
Everyone understand this, what I have written here?
Yes, sir.
I'll give you 2 minutes to note this down. Then we can write everything together and see how it looks. So here comes this revolutionary diagram, and I hope everything is clear with this diagram. Yes or no? We understand everything that is here? The first one is an RL circuit, the second one is an RC circuit, the third one is the LC circuit. If you get an LC circuit, you understand all the meanings here? Phasor diagram, phase difference, everything, yes or no? This
Yes.
is here your applied voltage E or V, whatever you call it. If you want to call it E, you call it E. If you want to call it V, you call it V. Doesn't matter. I have told you as E. Here it is written as V. Do we understand this?
Yes, sir.
Everyone understands this.
Yes, sir. But
No.
we haven't done LC, sir.
So that is how there are three circuits. So I'll request you to note them down. RL, RC, LC will not come, but if it LC comes, it's the same way we have drawn it. We have first drawn the current I. VL would be 90° ahead, VC would be 90° behind, and that's it, nothing else. So the net voltage will be VL minus VC. If VL is greater than VC, net voltage will be VC minus VL. If VC is greater than VL, I'll give you 5 minutes to note this down. Everyone understands this?
Yes, sir.
Note it down. Then let us move ahead with the next terms here. Now, what we can see is the value of impedance. In case of a LR circuit, the value of impedance is R square plus XL square. We understand this?
Yes.
In case of RC circuit, the value of impedance will be equal to R square plus XC square. In case of LC circuit, it will be XL minus XC. If XL is greater than XC, it will be XC minus XL if XC is greater than XL. Do we understand this?
Yes.
Tan of phi will be equal to VL divided by VR. That will be equal to XL divided by R. Here tan of phi will be VC divided by VR. That will be XC divided by here. Here phi will be equal to plus or minus 90 degrees. Do we understand this? Because the resistance is 0. We get this?
Yes.
Cos of phi in any case will be equal to VR by the applied voltage V. So it will be equal to R divided by Z. The formula is same here. It will be R divided by Z. Here the value of Z R. Here the value of Z is same as XL. So you have the value of this as 0. Do we understand this? Because R is 0. Do we understand this?
Yes.
Everyone gets this what I am saying here? I'll
Yes.
give you 2 minutes to note this down. I hope everyone is noting it down. The next graph, as you can see, is the variation of Z with frequency F. It's a very, very important graph. Direct question can come from this graph. In this, as you can see, when the frequency is 0, XL is 0. Therefore, the impedance of this circuit will start with R. Do we understand this?
Yes.
In case of the other one, when the frequency is very high, then XC will become 0 and then it will become equal to R. So at very low frequencies, this impedance is approximately equal to R. At very high frequency, it will be approximately equal to XL because XL will become very high and R will remain constant. Do we understand this?
Yes.
The reverse will happen in case of RC circuit. At very low frequency, the impedance will be approximately equal to XC, because XC will be very high and and R will be very low. But at very high frequency, XC will become 0, so the impedance will become equal to R. A very, very, very important graph here. In case of a LC circuit, the graph looks like this. When frequency increases, XL first decreases and then increases. Why it first decreases? Because at low frequencies, Z is proportional to XC, because XC is very high and XL is very, very less. At high frequencies, XL is very high and XC is very less, and therefore it increases. At one particular frequency, it will become 0. Z will become 0 when XC becomes equal to XL. Do we understand what is? Do we understand this?
Yes, sir.
I give you 2 minutes to note this down. So we move ahead in life, and we have the first question. In this question, you have to find the impedance of this circuit. And there is one thing that you would realize in these questions. I hope I will give you this question first, and then I'll try to make sense. You have to find out the impedance of this circuit. To start it off, the resistance of the resistor is given as 30 ohms, and the capacitive reactance of the capacitor is given as 40 ohms. You have to find out the impedance of this circuit. I'll give you 2 minutes to give me the answer. You can very easily see that the impedance of this circuit will be equal to under root of R square plus XC square, and it will be equal to 50. Remember, whenever such a question comes, in most 99% of the cases, both these things would be a Pythagorean triplet. Do we understand Pythagorean triplet?
Yes, sir.
3, 4, 3 square plus 4 square is 5 square.
Yes, sir.
They will be in the form of Pythagorean triplets. 12 square plus 5 square is equal to 13 square. So if one of them is coming 12, the other one will come probably 5. If one of them is 3, the other one would come 4. If one of them is 6, the other one would come 8. Do we understand this? Because they will try to make the question simple. Or it will be in the other pattern. If one is coming as 10, the other one will also come as 10. So the net resultant impedance becomes 10 root 2. Do we understand what I am saying here?
Yes,
It is going above or it's saying bye bye.
we got it.
Everyone got this? Yes or no?
Yes, sir.
Now I can move ahead with this question, and with only this question I can solve the entire thing. So I will move ahead. If I now say the frequency of this is 50 hertz, can you tell me the value of C? What will be the value of C? If the frequency of the circuit is 50 hertz, what is the value of C? That is the next question. You'll have 2 minutes to solve it. So how are we supposed to do this? We know that this 40 ohm is XC, yes or no? So XC is given as 40 ohms, and that is equal to 1 by 2 pi F into C, yes or no?
Yes, sir.
So your capacitance will be equal to 1 by 2 pi into 50 into 40. Do we understand this? Do we understand this?
Yes, sir.
Everyone gets this? Yes or no? No or yes?
Yes, sir.
Let me move ahead now, and let me tell you the next information. If I now tell you the RMS value of current, now as soon as you get the RMS value of current, everything becomes simple. The RMS value of current is 2 amps. Now can you tell me the rest of the things? Can you tell me what is the power of this circuit, can you tell me the value of cos phi? Cos phi is the power factor. Do we understand this?
Yes.
And what will be the value of E, which is the applied voltage? Whenever I ask you the value of E, which value am I asking?
RMS.
I'm asking you the RMS value of E. So you have these three questions. If you solve these three questions, that means your entire AC is done and dusted. So how are we supposed to do this? Any idea?
So power is 120.
So to find the power, you just need I square RMS and you multiply it by the resistance R. Yes or no?
Yes.
What is the value of I square RMS? That is 4 multiplied by the resistance is 30 ohms. So 120 watt becomes your power. Do we understand this?
Yes.
Cos phi. To find the value of cos phi, you just need to find out the value of R and divide it by Z. R is 30, Z is 50, so it becomes 3 by 5. Cos inverse of 3 by 5, I think it is 57, oh, that 53 degrees. To get the value of E, you can find the value of E by squaring VR square plus VL square, or you can also write it as IRMS. Remember, we are just talking about the RMS values. IRMS multiplied by Z. IRMS is 2, Z is 50. So your applied voltage ka RMS value would be 100 volts. Do we understand how this is done? Yes or no? No, yes.
Yes, sir.
Or this has gone above our head saying bye-bye.
We have got it.
I'll give you 2 minutes to note this down. Let me know once you are done. This is the next question. AC source is given to you. V is equal to 100 root 2 sine omega t volt. Then you are given a resistor. The VR is given as 60 ohms. You are supposed to find out the value of VL. I hope you understand the value of VR and VR. Which VR and which VL are they asking you? Which value of VR and which value of VL are they asking you?
RMS, sir.
They're asking you the RMS value of VR and RMS value of VL. You have 2 minutes to give me the answer. V square is equal to VR square plus VL square. That is correct. So this is equal to VR square plus VL square. That is correct, my dear friends. If you solve this, you will get VL as 80 ohm, 80 volt. Beta. I don't know from where you got this. God knows from where you got this. What is the value of V? What is the value of V?
100, sir.
60, 100, Pythagorean triplet. Why should I remember it? It's all crap. Why should I remember it? I don't have to clear JEE. Why should I remember it? It's all crap. Crap. It's all crap. Na 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 na. Okay. I would have to let go the disappointment and move ahead with the next question. I hope you understand the answer for the last one.
Yes, sir.
This is the next one. In the given circuit, find out the impedance of the circuit. Number 2, find out the current in the circuit. Well, the impedance of the circuit will be under root of 6 square plus 8 square. That will be 10 ohms. the current, that means RMS value of current will be VRMS. VRMS is 20 by root 2 multiplied by 10. So the answer will be root 2. I hope you got the answer. Yes or no? No, yes?
Yes, sir.
This is the next one. When an alternating voltage of 220 volt, which value is given?
RMS.
Is applied across a device X, a current of 0.1, 0.5 amperes. Which current? Which value?
IRMS.
Flows through the circuit as in phase with the applied voltage. When the same voltage is applied across another device Y, the same current again flows through the circuit, but it leads the voltage by an angle of pi by 2. Name the devices X and Y. Calculate the current flowing in the circuit if the devices X and Y are put in series. So, which is the device X? What is the name of the device X? What is the name of the device Y? Huh? No answer. The device Y is a capacitor. What is the resistance of the resistor? That is same as the inductive capacitive reactance, and that would be equal to 200 divided by 0.5. Do we understand this? Do we understand this? Do we understand this? I hope yes. I am not able to communicate. Maybe the voice has gone. Now, when they are connected in series, what happens is the impedance Z becomes under root of R square plus XC square. Both R and XC are 440. So this becomes 440 root 2. I hope everyone understands this.
Yes, sir.
Then I need to find out the RMS value of current. Remember, the RMS value of current is always equal to the RMS value of voltage, which is 220 divided by 440 root 2. So I think this is 1 by 2 root 2. Do we understand this? Yes or no? No, yes.
Yes, sir.
So this is the answer for this one. I hope everyone has understood this. That takes me to the next question, and this is the next one in line. When 10 volt DC is applied to a coil, current through the coil is 2.5 amperes. If 10 volt 50 hertz AC is applied, the current reduces to 2 amps. What is the reactance of the coil? Remember, any coil has a resistance. It's also inductor. It has a inductive reactance. That is what this gentleman aspires to find out. You have 2 minutes. When a 10 volt DC, it is DC, Purana DC. Current is 2.5 ampere. From here, I can find out the resistance of the coil. Resistance of the coil will be 10 divided by 2.5, 4 ohms. Yes or no? No, yes.
Yes, sir.
When 10 volt AC is applied, remember that is RMS value. You can find out the value of Z. The value of Z would be 10 divided by 2, 5 ohms. As soon as you get 5 ohms and 4 ohms, you know the reactance of the circuit is how much?
3.
3 ohms. Pythagorean triplet, my dear friend. Pythagorean triplet, my dear friend. Pythagorean triplet, my dear friend. This comes a question which encompasses everything that we have studied. So I will not waste any time in reading out the question. The question is given in front of you. All the questions that are possible here are given. You have 2 minutes to give me the answer. So let me do it step by step to find out the impedance of the circuit XC. You have to do 1 by omega C. That is nothing but 1 by 2 pi F into C. And once you do it, I think you are going to get 100 ohms. Yes or no?
Yes, sir.
Then to get the value of Z, you just have to square it, R square plus XC square. I told you one is coming as 100, the other one will come as 100. So that you get the impedance as 100 root 2. Do we understand this?
Yes.
To find out the value of power factor, you can just find the value of cos phi, and the value of cos phi will be r divided by z 1 by root 2. So your angle phi becomes 45 degree. Yes or no? No or yes?
Yes.
Who will lead? Will the current lead or will the voltage lead?
Current.
Current will lead voltage by a phase angle of pi by 4 or 45 degrees. Yes or no? No or yes?
Yes.
Then you have to find out the value of current. That means you have to find out the value of RMS current. How do you find out the value of RMS current? VRMS divided by
Impedance.
so how much is VRMS? Remember 200 volt is given, so that will be VRMS. So this will be 200 divided by 100 root 2. Yes or no?
Yes.
So I think you will get it as root 2 amperes. Yes or no? The maximum value of current will be IRMS multiplied by root 2. So the maximum value will become 2 ampere. Yes or no?
Yes, sir.
The voltage across R. So which voltage are they asking? They are asking the RMS voltage. Yes or no? So
Yes.
that will be equal to 100 root 2. The RMS voltage across capacitor will also be 100 root 2. Is everyone getting
Yes.
this or not?
Yes.
To find out the maximum voltage, you just multiply it by root 2. You will get this. Yes or no?
Yes, sir.
P in a dabba means average power. Average power is I square RMS multiplied by R. So that will be 2 multiplied by resistance is 100. So that is equal to 200 watt. Yes or no?
Yes, sir.
Average power across the resistor will also be same. What about the average power across the capacitor? It will be 0. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this?
Yes, sir.
Now there is a subordinate question here. There is a subordinate question here. If you solve that, that means everything is fine in this universe. In the same question, if the current, the voltage is given as a waveform, this is the voltage given as a waveform as a function of time. Can you write the value of current as a function of time, VR and VC as a function of time? Do you remember what I told you? Yes or no?
Yes, sir.
So can you write the current VC and VR as a function of time? I'll give you 2 minutes to do this. So what is the answer for the current to the circuit? Remember, the maximum values of current is 2. Yes or no?
Yes.
So this will be equal to 2 sine omega is 100 pi. Yes or no?
Yes.
So 100 pi into t, and the phase angle, will it be leading or will it be lagging?
Will be leading, sir, by
It
40.
will be leading by a phase angle of pi. So that becomes the formula for this. Yes or no?
Yes.
What will be the value of VR as a function of time? What is the maximum voltage? Maximum voltage is 200. Yes or no?
Yes.
Sine of, will it be in the same phase or will it be leading or lagging? It will be in the same phase. Therefore, this becomes the formula for this one. Do we understand this?
Yes.
What about VC? Again, the peak value is 200. What will be the value? Will it be leading, lagging, or in the same phase?
Lagging by pi by 2.
So plus 45 minus 90 degrees. Do we understand this? Or this has gone above our head saying bye bye?
We got it.
Bye bye, I'm going, bye bye, I'm going, bye bye, I'm going.
We got it.
Congratulations if you have got it. That takes us to the last part of today's class. We are still not done with AC, but hopefully we'll be able to wind up your electromagnetism. AC, small part is remaining, and EM wave is remaining. But before going on to that, this is the last question for today. A 9 by 100 pi, why it is given? So that you know the value of omega L comes good. And at 12 ohm resistance, as soon as you see 12 ohm, you should not look anywhere else, because when you know what is 12 ohm, you should be able to understand what will be the other one. And a resistance of 12 ohm are connected in series to a 225 volt 50 hertz AC source. Calculate the current in the circuit, RMS value, and the phase angle between the current and the voltage source. Who is leading, who is lagging? You have 2 minutes to show your talents, else I will show my. It is 37 degrees, and that is what you should get. First of all, you have to find the value of XL, and you don't have to even find it out. You will understand that this value will come as 9 ohms. Yes or no?
Yes.
Then you will get the value of Z, 9 square plus 12 square ka root, that is 15. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Then you find out the RMS value of current, that is the VRMS value 225 divided by 15, and the RMS value of current is 50 amperes. Yes or no?
Yes, sir.
You can find phi as tan inverse of XL 9 by 12. So you can write the answer as tan inverse of 9 by 12 or 3 by 4. 37 degrees. Yes or no? No, yes.
Yes, sir.
Everyone understands this?
Yes, sir.
So this is the last one since you have done it fast. So I'll give you one more to wind off this class. Do it fast. You have only 1 minute to do this. Remember, Pythagorean triplet is the most important. When an inductor coil is connected to an ideal battery, I think we have done this, right? I think we have done this. So I think we are done with all the questions that can come in this category. I think we have done this question before from that different notes of mine. The next class, that is tomorrow, one circuit is still left. What circuit is left? You have done LR, we have done RC, we have done LC. Which circuit is left?
LCR.
The combination of all of these three together, LCR. And that will be covered in the next class, that is tomorrow. And we'll also try to cover your EM waves, which is a very simple chapter, and I will just give you the main points that you have to remember while attempting any questions. So I'll see you tomorrow in the next class. Take care. God bless you all. Everyone has understood what we have done in today's class?
Yes, sir.
If you missed any of the lectures, you can go back and watch the recordings, and if you have any doubts, you can always come up to me. Take care. Bye bye.
Thank you, sir.